Hello everyone, welcome to lecture on Tuesday. I'm going to look at Bluetooth. We stopped at description about the Bluetooth signal, and I stopped when I was discussing how the parameters milliwatt and dBm are related. And if you remember, we looked at this table, which you can see the range of Bluetooth is relevant to the maximum permitted power. And we have different classes of Bluetooth. So I'm hoping that everyone understands how we can convert watt to milliwatt to dB and dBm by end of this lecture. One thing is to remember that, as I explained, higher the power is directly related to a larger range in meter. And another thing that I mentioned was when we are looking at particularly the range parameter, we are looking at theoretical range. And the actual or practical range is related to the way that transmitter and receivers are located. And if you remember, I explained that line of sight, a straight line between the transmitter and receiver, without any obstacles, without any reflection, without any observation on the way, that would be the ideal path between transmitter and receiver. And that would provide theoretically up to 100 meter in this case for class 1. But in practical, it will be very difficult to provide that kind of channel between transmitter and receiver, and because of that, the practical range would be smaller than what we have here. So let's move and look at a logarithm relationship between the milliwatt and dBm. So I explained that when we are looking at any system, in this case we are looking at amplification system. We are looking at one input power that we are giving to that system and output power that we are expecting from that system. The reason that I'm saying we are looking at amplification system is because any signal, no matter it is Bluetooth, it is Wi-Fi, it is what kind of protocol it is following, we need to make it strong enough to be able to transfer wirelessly. For that reason, we require to have such a system in place to make that power strong enough to travel. So we are looking at different classes, we are looking at different ranges, and also looking at different required power. In some cases, we are looking at very large scale. That means that here we need to have very nice gain. Gain means that the amount of the power that we expect to come out of that system should be large compared to the power that we are giving to that system. That means that the gain is very high. And that is related to, higher distance the wave can travel. And also when we have a smaller gain, when we expect a smaller power range from outside of that amplification system, we expect shorter distance. Why do we need such a system, and why we don't make all of them as strong as possible? The reason is because higher the gain, most of the time is equal to more expensive devices. And sometimes it's not feasible to apply such a system for short range applications. One example is personal area gadgets, PAN. So when you have Bluetooth gadgets that require to be connected within 1 or 2 meters, it's not feasible to use very strong, powerful, and power-consuming devices to provide that range. So it is reasonable to use shorter distance gadgets and less powerful systems. Now we are going to be familiar with gain in form of decibel and dBm. Decibel is a very typical parameter that we use to define how this system is working and how that output power is relevant to input power. The way that we measure it is with a logarithm of base 10, and you can see that we have this equation here. So I have P2 on the top and P1 at the bottom. And we have this multiplication in 10. Don't forget about this because I remember from previous years, many students they forget about this 10 that is being multiplied in the logarithm. That makes it in a range that is, easier to understand. Otherwise, the range would be difficult to differentiate from each other. So this would give us the decibel, or the gain of that amplification system. And another way of looking at that system would be called a dBm. So when we are looking at dBm, that means that we know the range of P1. That means that we are looking at a particular system that is giving response to 1 milliwatt. I'm going to move to the next slide, which I'm describing it a little bit further. So instead of P1, if I put 1 milliwatt, that will give me dBm. So the M, the letter M, is coming from the fact that I'm providing P1 with 1 milliwatt. That is very important to remember. In the future or in your workplace, if you came across dBm and dB, you should be able to differentiate them. So that equation here is showing the relationship between the dBm, milliwatt, and the output power in milliwatt. So if I have this equation for you, and I ask you how much is the input power in this case, you would know right away that the input power is 1 milliwatt. And again, if I'm giving you the output power in range of watt or milliwatt, and I'm asking you to convert it to dBm, you can easily use this equation and put the value that I have given here on the top for milliwatt, or here for the dBm, and calculate the other one. So we are going to look at some examples, and we do some conversions, and I have some examples and practices for you, and I'm hoping that becomes very clear for everyone. Now, let's say that in this case, I'm looking at class 3 from the table. Let's go back and check class 3. So class 3, the maximum power is 1 in milliwatt. We want to check how that one is giving 0 dBm, how that happens exactly. So I'm going to use this equation. I have the 1 here because I want dBm. I'm going to put the other one from the table for the maximum permitted water instead of the P, and I'm going to calculate that. So this is the equation. I'm just replacing the top, the power in milliwatt, with number 1. This one is coming from the table. And this one is coming from the fact, from the definition, that P1 should be 1 milliwatt to give me the value in dBm. So this calculation is going to give 0 dBm. I have my calculation here. So the way that we use it, okay, so I have 1 here. If you use logarithm, without any base, the default base is 10 in any calculator. So you can see the logarithm of 1 is equal to 0. It is multiplied in 10, but again it is 0 dBm. Alright? Now, let's take a look at another example. Here I have another example. So this example is in a case that we are actually checking how that milliwatt is related to dBm if we change things around. That means that you may convert the logarithm to exponential. So if you remember how the logarithm worked, I explained in the lecture last week. But if you're a little bit confused about it and you are relying on calculators, I really advise you to go back and look at these links here and just make sure that you remember how the logarithm and exponential function were inverse of each other. And then come back here and continue on the lecture. For those of you that remember how I explained the exponential function and logarithm relationship, go ahead and try to do this exercise. So here I took a part of that table that has the classes and the milliwatt power. Now we want to convert this milliwatt to dBm. So if you go back, you have the values here. So the answer is already given here. But I want you to be able to calculate them yourself. So just imagine it's final exam and try to calculate it yourself. I said that you are allowed to use calculators for, your final exam, but it would be nice if you can understand how the process is done. So in this case, again, we are using the equation. What equation? Where this equation come from? Here. That is the equation we are going to use over and over. Conversion of milliwatt to dBm or vice versa. So here the milliwatt given is 100. So the 100 is going to replace the P2 and P1 is replaced with 1 because we want dBm. If I have one question in final exam asking you to give me dB, not dBm, that means that I most likely have provided P1 and P2, both of them together. But in this case, I'm only providing the maximum output power, which is the P2. And I'm asking for dBm. So the question is telling that you need to put 1 here. Now, again, let's go to the calculator. So I'm putting 100 and I'm calculating the logarithm of that. So it's giving me number 2. And 2 will be multiplied in 10 and it will give me number 20. So this will be number 20. I'm going to just write it here, number 2. Let's go back to the table and check. Did that 20? So that's correct. I forgot to write it, 2 multiplied in, well, let's write it 20. I don't find my multiplication sign right now. So that is 20 dBm. The way that we write dBm is we keep the letter B capital and we write the M small. Now, I give you some time to calculate the next ones. So we have 10, 2.5, 1, and 0.5. Go ahead and calculate them right now before I continue and I calculate them myself. Okay, I'm hoping that everyone managed to get correct answers. So I'm going to do it myself. The next power is 10 milliwatt. So I'm going to put 10 in my logarithm. That will be 1 and 1 will be multiplied in 10 and that will give me the answer 10. Let's go back to the table and confirm that. Yeah, so class 1.5 is giving me 10 dBm and that is relevant to approximately about 20 meter range. Now, going back here, that is 2.5. The logarithm of 2.5 is equal to 0.39, so that can be rounded up to 0.4. Now that can be multiplied in 10. Let's go back here, and you can see that we have 4 dBm here, which is relevant to about 10 meter range. Now, let's go and look at the next one. The next one is 1 milliwatt. So the logarithm of 1 would be 0 and multiplying in 10 will give me 0 dBm. I did this in previous slide. Yeah. Let's look at 0.5. What happens when we have 0.5? 0.5 logarithm is minus 0.3. Now that's minus 0.301 and the rest of the numbers, that can be rounded, and when it is multiplied in 10, that will give me minus 3. Let's go back here and you can see minus 3 dBm. It is interesting because when we are looking at dBm, we might have negative values. That's not a bad thing, that's completely normal. And we actually do have lots of negative dBms. You will see that a lot. especially when you're looking at data sheets of components. When you go to your workplace in future, I am sure that you will come across many components, and when you're looking at their data sheets, you will see negative dBm power. So, and that is completely normal. That will give us very small range in this case. So you can see that the relationship here. So the range is coming from like here is the way that it is moving is slightly different from the way that this dBm is changing. But the thing that is consistent is that the range is very high when we are looking at that high power, and it comes very short when we are looking at lower power in Bluetooth transmitters. Now let's look at how that pairing can be established when we are looking at Bluetooth. So Bluetooth is using Piconet. That is the name of the network technology that this protocol is using. Each Bluetooth device has a small computer chip with a Bluetooth radio and software. So a lot of the management and decisions that are being taken care of is through that software that is built inside the Bluetooth. Communication between devices occurs over networks called piconets or personal area networks. So remember when we were looking at different layers, wide area networks, even cloud, and even macro range networks. Personal area network was one of them. Individual networks of devices connected using Bluetooth protocols. So in a very generic form, we are going to have one device that's going to act as master, and we are going to have 7 other devices that are acting like slaves. That's a very typical way of just talking about Bluetooth connectivity. In this case, we have only 7 slaves and we have only 1 master. But this is not the only scenario that you would see Bluetooth is connecting. There are even slots and odd slots of time in which a packet can be transmitted. For single slot situations, the master transmits data in even slots and receives in odd slots, while the slave receives in even slots and transmits in odd slots. So they don't interfere with each other. That's the reason why we have odd and even time slots. So if there is more than 1 slave, how does the master transmit the packets to all of them? That's a very nice question. So this algorithm is called round-robin scheduling, and master handles each slave without priority in circular order. That's one way of that master managing how I'm going to give priority to this slave to the other one. So this can be done using round-robin scheduling. The switching is very important. How fast that master is managing the switching from this slave to that slave, and typical frequency that switching is being done is 1060 times per second. Now, I mentioned that is not the only scenario that you would see in Bluetooth. Another scenario would be when we have only one-to-one topology. So one of the devices is becoming master and another one is becoming or acting as a slave. So they switch the position sometimes. So the other one becomes master, the other one becomes slave, depending to situation. And sometimes the master is not only paired with one slave, it is also acting between multiple other slaves also. This type of network is called ad hoc computer network. You guys probably know that better than me because of the type of the degree that you're pursuing, and the hardware should be also in place in order to have such a technology known as Beaconet. Now, these stages are very typical stages that when we are looking at Bluetooth, we need to be aware of them. So stage one is called inquiry. So if you imagine you have two devices and they want to connect with each other. If two Bluetooth devices know absolutely nothing about each other, one must run an inquiry to try to discover the other one. You're aware of this inquiry as scanning. So many times when we have our device, when we are using our phone or computer or any other device, we have this option of scanning. That means that you're checking that what Bluetooth device is available to be connected to you. And another thing that you do is you make yourself discoverable, or you make yourself available to be connected. So the inquiry and paging, which is the stage 2, they are kind of interconnection. They can be done in one step or in different steps. So first of all, you need to make sure that you are available yourself, you are discoverable yourself, and the second one, you need to make sure that you're scanning, you're checking what devices around you nearby are available to be connected. If you're not discoverable and the other device is running the scan, they can't see your device. So both of the devices that want to be paired, they should be available. So when the connection is being established, so one of the devices is acting as a slave, another one is acting as master, and so they make the connection that way. Now we also have different types of the action or activity between Bluetooth devices. So the inquiry and paging, that is the initial steps for making that pairing, that connection. But once that connection is established, the type of the connection might vary between this device and that device and this device with another one. So you might have multiple of things connected to each other, but the way that they are connected, the way that they are communicating with each other, it might be different. So some of them might be in active mode. Active mode is that they are sending and receiving actively. So they are like in top priority, and they are the most recent connection and connectivity between two devices or multiple devices. Some of them might be in sniff mode. So this sniff mode is that they are kind of being used frequently, but at the moment they are in power saving mode. They might come back to the active mode, but at the moment they are in sniff mode. Another mode that they might be is hold mode. Hold mode is temporary power saving mode again, but the device is sleeping for longer period of time compared to sniff mode, and it can return back to active mode if that period of time is over, or just the device is inquiring again. We also have another mode, which I always make fun of it. It's called park mode. Park mode is very deepest sleep that one Bluetooth device can go in. It's someone that is in a party but is sleeping, so it doesn't know what's happening in the party. So that would be the park mode. So they are kind of in standby mode, waiting for the inquiry to come back to active mode. That's why when we are using our devices, the most recent one is the one that is being referred to. If you have multiple headsets, the one that you used yesterday is going to be the default connection when you're turning on your computer. And if you want to change that, you just need to make sure that you have that pairing done again. So that is nice. If you're interested to know more about these modes and connections, you can look at internet. There are loads of information available. Now, the security and privacy of Bluetooth is also a nice area for a study. So in this slide, I have small information taken from this website. If you're interested, you can go and read that. I'm just going to read from my paragraph here. Pairing usually requires authentication process where a user must validate the connection between devices. The flow authentication process varies and usually depends on interface capabilities, sorry for my bad English, of one device or other. Sometimes pairing is a simple, just works operation, where click of button is all takes to have the pairing done. And sometimes it's more than that, and you require to enter a PIN. Sometimes that PIN is a random number, and that means that you have extra cautious, extra security layer added. Recently, when I was installing my camera, I had one of those devices that I required to have very long code enter to have that connection done because it was replacing my webcam. So you might have that kind of security in place when you're connecting your Bluetooth device to another device. In my case, it was my laptop. But sometimes it's just a matter of clicking on confirmation button just to make sure that you're happy with that connection. Of course, things can go wrong, and there might be more security aspects coming up in the future. But for now, because it is related to your personal area network, and most of the time distance is avoiding that pairing process, so that privacy is kind of being taken care of by only the range. But it is a very ongoing process, and more advanced devices, especially those, for example, that are recording your voice or recording your image, they probably require more security layers, and for example that PIN that I said. If you're interested, you can look at online resources. It's a very nice and nice area to look at and study. If I'm not mistaken, next slide is the FHSS, which I explained in the lecture. So if you remember what I explained in the class, I'm just going to quickly review that again, just in case if you have missed the lecture. So the reason that we are using FHSS is that we want to spread the spectrum. As you noticed, the power that we are using is very small. That power is only able to transfer very small amount of bandwidth. That is why we can't send or receive very high quality videos or very high capacity files. Even that small amount of data that we are sending or receiving using Bluetooth should be broken apart. So we should divide it in separate frequency bands and send it in different time slots. FHSS is the technology that is providing that breaking apart or spreading the spectrum. That's the reason why it is called frequency hopping spread spectrum. The way that the hopping process is done, we are dividing the time slot. It means that we are looking at what I'm sending at a time, what I'm sending at my 0 second until 1 second, and what I'm sending from 1 second to 2 seconds. That means when I'm saying time slot, I'm looking at literally what I'm sending now, what I'm sending in 1 second, what I'm sending in 3 seconds later. So when we divide the frequencies, that means that I have smaller bandwidth that I'm sending. Why we do the hopping? The reason we do hopping is we want to have a pattern. Remember when I was talking at even and odd slots, that was changing the time to give allocation in terms of time for frequency that is being transferred. Now here, we are not only looking at time, we are also dividing small portions of the bandwidth, and we are deciding what part of that bandwidth is being sent at what time. So in this example that we have, from time 0 to t1, we are sending frequency bandwidth of f2. And when the time is moving from t1 to t2, I'm sending frequency of 3. And when it is hopping to f1, that is happening only when I am in time slot of t3, and so on. So we end up with a pattern. A pattern means that if I want to write a sequence that this diagram is following, that would be f2, f3, f1, f3, f3, f2, f1. So that would be the pattern that this particular example is following. There are many reasons I explained why we do need this pattern. And one student asked what happens if you have multiple of them, how that can be done. So I explained exactly how it is being managed and without interferences between two devices. So that would complete this lecture. And if you have any question, feel free to ask me. I'm going to have, I think if I'm not mistaken, a couple of more slides comparing Bluetooth with infrared and another protocol if I'm not mistaken, and then we move to another, or I think I have more. I have few more slides for Bluetooth, and then we move to another protocol. Okay, so if you study these slides and you watch this video and you still have some question, feel free to ask me in lecture on Thursday. See you guys, bye-bye.